Awesome stuff, guys. So next, we're going to switch our focus from the power of systems to the science of data and go from travel around our planet to travel beyond the stars. The possibility of intelligent life in the universe has fascinated us since the beginning of mankind. It's been a favorite topic of science fiction writers, spawning classics like War of the Worlds by H.G. Wells. It's led to UFO sightings and been a constant source of inspiration for filmmakers. Just think of E.T., Close Encounters of the Third Kind, Star Trek, Independence Day, Avatar. All of these show our incessant focus on life beyond our planet. And it's also been the sole focus of an organization started over 30 years ago with just one singular mission: understanding and explaining the nature of life in the universe. Take a look. Getting the goosebumps. To tell their story, please welcome astronomer from the SETI Institute, Dr. Jill Tarter.
Hello, good morning. I co-founded the SETI Institute back in 1984, and I hold the Bernard M. Oliver Chair for SETI Research. SETI, I hope you know by now, stands for the Search for Extraterrestrial Intelligence. And our mission, as Jake said, is to explore, understand, explain the origin and nature of life in the universe. So I led the search for evidence of extraterrestrial intelligent technological life for decades. And now, as a member of the SETI Institute Board of Trustees, I serve as the chief cheerleader for all of these explorations. And I'm happy to tell you that we're listening. And I'm really happy to tell you that with the help of Apache Spark and IBM Cloud Data Services, we're learning how to listen in new ways, and we'll be able to listen even better in the future. So every day for 12 hours, we use the Allen Telescope Array in Northern California to explore stellar systems that we know host at least one planet. We listen with our radio telescopes for signs of engineered signals. And this is a very data-intensive task. The Allen Telescope Array consists of 42 antennas, each of which generate 18 gigahertz of analog data. Now, we have to filter that down and digitize only a small portion to produce 130 gigabits of data per second that we work with for real-time analysis. FPGA-based beamformers aggregate these data inputs to create data streams from 3 different spots on the sky, 3 different planetary systems at the same time. And then we listen. We listen, actually, our computers analyze in real time. We listen for a specific type of signal, obvious narrowband artifacts, ones that stand out from the natural astrophysical background. But there's also a human-made background. Our own astonishing technology and all of our smart gear communicating with each other and with satellites over our heads create a really daunting challenge for our listening. Requiring that the currently detected signal doesn't match signals seen recently from other directions on the sky helps. Requiring that the frequency of the signal changes over time in ways that it should if it's really coming from a distant planetary system helps. Looking in 3 directions at the same time helps. An extraterrestrial signal should be coming from only one. And requiring minimal persistence also helps. The signal needs to be detectable during immediate follow-up observations, while the noise background will be changing continuously. But we actually need more help. Apache Spark and IBM Cloud Data Services have begun to help. Over the past 4 years of listening, we've created large databases containing information about more than 100 million signals that we have detected, and we've archived raw data from the frequencies surrounding all of these detected signals. And our current system has classified each of these signals as interference. Since this summer, we've been working with the IBM team to use Spark Analytics to explore these signal databases. Could we have been wrong? Might there be a real signal that we've incorrectly classified as interference? Are there better or faster ways to find these obvious narrowband artifacts that we've been listening for? Are there other types of signals that machine learning might allow us to capture on the fly? Are there ways to modify our observing schedules so that we can avoid some of that interference? And can we find other diagnostics that can help us cut down the persistence requirements so that we begin to have some sensitivity to fleeting signals? Capabilities like Apache Spark are opening up these previously unexplored data sets. We want to do what we've been doing faster, and we want to do new things that we didn't know that we could or should do. And we're making real progress. Ultimately, we want to be able to analyze that overwhelming fire hose of data flowing from our unique antennas. We want to listen better. We really want to find a signal. So, I'd like now to please welcome to the stage General Manager of IBM Analytics, Beth Smith.
Thank you. So I know everybody in here is on the edge of their seats waiting to learn what you all learn as you go through this. And you know, Jill, I know you know that IBM and NASA partnered to put a man on the moon. And you know, now we're 45 plus years later, and it's IBM, SETI, and NASA partnering again around applications that are 100% fueled by data. The work you and the SETI team are doing is just really incredible. Now, I also know that this audience would like to learn more about you. And, you know, how did you get started in data science?
Well, Beth, actually, it was a fantastic accident, right? So, my first year as a graduate student, I learned how to program a PDP-8S in Octal. Right.
You have some colleagues over there, I think.
Who are old enough to remember that, yes? All right. And then I was in graduate school for many years. And about the time I was getting ready to leave, this X-ray astronomer had a fabulous idea of how to use radio telescopes and piggyback the observations to do SETI at the same time they were doing radio astronomy. Cool idea. He had no money. He went begging. Someone gave him this old machine, and he came to recruit me. So I got so excited to think that for millennia, we've been asking the priests, the philosophers, the shamans, anybody we thought was wise, about what we should believe. But suddenly, in the 20th century, engineers and scientists got to be part of this game, and we could look for what is, rather than ask someone what to believe. I got hooked, and And I've stayed hooked.
Never looked back.
Never
Never looked back.
looked back.
Always looking forward. So, before we continue our discussion, I do want to take a moment to share a few things with the audience. Data is becoming infused in every single decision made in business, not just in science. And the evolution of data science is founded on open access to that data and expertise, making every single business application smarter. You know that today, 80% of enterprise data is still untouched. Data science is opening doors to all of that data and enlightening users across the enterprise to be able to see more, know more, and do more. The applications that are born today are taking businesses into the cognitive era. There is no doubt now is the time for data science. 4 months ago, we announced our commitment to data science and specifically Apache Spark, much like Jill talked about. And in this decade that is being defined by data, Spark is the most important new open source project. It truly is the analytics operating system for applications that are fueled by data. And through Spark, data science acceleration delivers innovation in the cognitive era. We at IBM are committed in several ways. We're well on our way to educating over 1 million data scientists and data engineers globally. We're also embedding Spark in our analytics and commerce platforms. And we opened the first Spark Technology Center right in San Francisco, the hub of data science innovation. So Jill, SETI is a good example of industry-changing work, no doubt. Our next guest is also doing some pioneering work in data science. Please join us in welcoming Ed Dumville from Silicon Valley Data Science. Ed? You may not have known, but Ed founded O'Reilly's Strider Conference, and that draws more than 5,000 data science professionals together around the globe. Ed himself has deep expertise in the field of data science and is really a visionary in this emerging technology. Ed, I find it fascinating. You lead a team of data science professionals, and they have one charter: to solve tough business problems with data. My guess is this audience has a similar mission. I also understand that your team has a very interesting application around Caltrain. Can you tell us more about that?
Yeah, absolutely. So, every company has its interesting founding myth, right? Were you in your garage, in your parents' spare bedroom when you started what you were doing? Well, for us, a few years ago, a sort of plucky band of data scientists and data engineers, we ended up in our first office right by Caltrain in Sunnyvale. This is a very noisy place to be. Every 18 minutes or so, 5 p.m., these trains come by, they're making a real noise, and the horns blowing and so on. And there we trying to pitch these fantastic organizations on how smart we were, having to mute the conference call, every so often as this train would come by. Well, we decided we'll turn lemons into lemonade. A lot of our employees get the Caltrain up and down the Bay Area. Unfortunately, it's not entirely clear always when the train will arrive. There are some issues. You've probably been there, and sometimes the sign will say your train's late when it's actually on time. Sometimes it'll say it's coming in 2 minutes, and it's 10 minutes before it turns up. So we thought, well, let's put our analytic capabilities to try and fix this problem for ourselves. So we pointed a camera out the window, okay, can we use image recognition to see which train's coming when? We put a microphone out, can we figure out, what a train horn is versus a truck, and so on? Can we mine Twitter, the social media, as well as actually using Caltrain's own schedule? And the result of this is that as an R&D project, we're able to put together an app which you can get in the App Store, which enables you to see when your train is coming. And one of the fun things about it for us is it's a soup to nuts data application. We're running Spark and Hadoop and doing all the data integration. We're doing fun signal processing on the audio. And at the same time, we're creating a self-reinforcing app. As more riders use the app to figure out when their train's coming, we have more geographical data as their phones travel along the line. So our app is going to get better and better because of the use of the data.
Excellent, excellent. Something that definitely benefits people in the room and other colleagues and other folks around, particularly the state of California. So I know you have some other great examples. Take just a moment and give us another quick lens into some of the industry work you're doing.
Yeah, so we're working a lot to help businesses who've been around for a while really kind of make a change up by using data in a smart way. And one of the things actually to do with space that fascinates me about data is the way that we are no longer bound by what exists in our physical investments. You know, when it was a bit embarrassing when the Hubble Space Telescope went up, right, and the manufacturing defects meant we couldn't get a clear picture. Well, how do we solve that in the end? With math, right? By correcting for what actually happened. And so we have been working with a large global brand, you know, consumer products. These guys don't have the direct connection to the customer that a Google or a Facebook do. They just can't. But they still need to make decisions based on analytics. And so we're able to create, using a variety of data sources, good enough proxies for actually having this one-to-one relationship so they can understand, well, which line to release in this country or this territory. Another example, as we helped a large national retailer, again, you know, these guys are competing against Amazon and all these other firms that have developed wonderful logistics models, but they've already got this existing brick and mortar investment. How can they keep up? Well, again, the answer is you can use data science, predictive analytics to make it seem as if they are an online store by joining together the data and the inventory from all around. That's actually one example where we use Spark. We had that in production over Black Friday last year. Anyone in retail knows that's a big deal.
Yep.
And Spark was really important.
Good. And you had some good examples that really help us see how you're helping others change the way they do things going forward. I'd like to now ask you, Jill, what do you see that's going to be different in how you do your job going forward?
Well, today, my team are the experts, and we're trying to find signals by asking questions based on preconceived notions. But in the future, starting now, we can begin to ask questions that are based on the data themselves and get smarter.
I think that's really important. You know, the art of leadership, I think, now is the art of knowing the right questions to ask. And it really changes the game for how businesses need to think about using that data as they become cognitive. It's a leadership and an organizational challenge too.
Right, and it's really about really listening to the data and helping it guide you as well. That's great. So I have one more question for both of you. We'll start with Jill. What excites you the most about the promise of data science?
Well, so for me, it's all about speeding up the search and extending our reach. So take a minute. We're trying to search this really complicated 9-dimensional volume of search space to find a signal. So let's set that volume equal to the volume of the Earth's oceans. We've been doing SETI for 50 years. So far, we've explored just one glass out of that ocean.
Wow.
Right?
Wow.
So data science will allow us to systematically and much more quickly explore that ocean. And we will continue the process of changing the appropriate verb from to believe to explore. And of course, I'm really excited that we might succeed.
Absolutely. So what about you, Ed? What excites you the most?
Well, I think what excites me is probably what equally terrifies me at the same time. And this is closer to the planet that we're standing on, that the way business is changing, the way disruption is happening is ever faster. Now who'd have thought that the taxi industry, music industry, movies, retail, everything, auto manufacture, now all of a sudden is being revolutionized by companies based in Silicon Valley. But what have they got, right? They don't have long chops in making cars or movies. They understand how to create a data machine. And the data machine can eat everything else up. They can learn the industry, but they've got the connection. And so for us all, we're in a world where increasing parts of our lives are digitized. And how do we make sense of that? And ultimately that is, I think, the terrifying thing if your competitor is doing it. The exciting thing for you is that the way a business makes sense of its own operations, its competitive landscape, its customers, is with data science that brings it all together and helps them understand the opportunity.
Excellent, excellent. Well, I know the audience really appreciated both of you sharing your perspectives, and I think you've really helped us think about that science of data and the art of possible going forward. So thank you.